Hello, and welcome to the Publishing Executive and Book Business webinar, How AI and Natural Language Processing Can Increase the Speed and Quality of Publishing, sponsored by Synveo Publisher Services. My name is Matt Steinmetz. I'm the Publisher and Brand Director for Publishing Executive and Book Business, and I'm your host and moderator of today's event. Before we get started, I just want to take a second to point out there's a Tips for Attendees widget on your console. It's the blue icon with the wrench on it. If you missed the tech tips video we played leading up to the webinar, or you have any technical issues, you can always click this widget for more information. I also want to remind you you can submit questions at any time during this presentation. We're going to hold all questions until the last 5 or 10 or 15 minutes, but please submit them at any point. So we've got a lot to get to today. I want to keep moving along here. So for quite a few years, artificial intelligence has seemed like just another buzzy term with vague implications for publishers. But now we're starting to see publishers really putting it into action. Through a range of applications, AI and natural language processing are being used by publishers to streamline workflows, produce higher quality content, improve the author experience. So today's webinar is going to explore some current use cases and some future applications of AI and NLP within publishing, and how they're combining to make research and publications more timely, more relevant, and more useful. Really excited that we have 3 fantastic speakers joining us today. I'm going to quickly introduce them, and you'll hear from each of them. Francis Xavier is VP of Operations with Synveo Publisher Services. He's been associated with the print and publishing industry for over 27 years. His experience spans engineering, international customer service, quality, training, and management. He joined Synveo in 2004 to lead production operations with a particular focus on technology. He's proved instrumental in developing key differentiators for Synveo, such as their Smart Suite production engine. Previously, he spent time with Times Publishing Group in Singapore, where he spent 8 years working for leading publishers, including Time Inc., McGraw-Hill, Newsweek, and Fortune. Next up, we'll have Stuart Gardner, Global Production Director for Taylor & Francis. Stuart joined Taylor & Francis in 2014 and is responsible for procurement and management of peer review support, production, and distribution services for Taylor & Francis's 2,500 academic journals. And then finally, we'll have Neil Blair Christensen, Sales Director at Unsilo. They are an AI and NLP provider that is launching manuscript evaluation solutions to aid pre-accepting screening of content. He's held publishing roles in Europe, Asia Pacific, and in the U.S. with Monksguard, Blackwell, Nature Publishing Group, Wiley, University of California Press. And he's worked in production, editorial, product, and business development, from journals to clinical solutions and across the humanities, social sciences, health, and life sciences. So our 3 panelists bring a wide breadth of experience. Really excited about what they have to offer us today. So really, we're going to dive in here, and just to provide a little bit more context, I want to set the table. Our parent company, NAPCO Media, has a research arm called NAPCO Research. We conduct extensive surveys and research across many of the B2B markets that NAPCO serves. One of them being the marketing industry in general, brand marketers. So last year, NAPCO Research published the findings of our Marketing Technology Stack Investment Trends Research Project, which is subtitled the tools that top brands are purchasing in 2018, and you should consider too. Now, like publishers, brand marketers have a lot of content, and they have a lot of customer data. And our research showed that AI is certainly a growing, but still relatively new concept for many brands. 31% of brand marketers said they plan to invest in AI in 2018 or now in 2019. In that same study, we found that larger companies with more resources tend to be first movers when it comes to AI. We observed that AI had an 11% higher purchase rate among quote-unquote richer marketers. Not that surprising, you would probably agree, but I think it's a nice way to frame today's webinar. 2 observations. 1, we're still in the early-ish days of widespread AI adoption and applications. And 2, larger companies, who generally have more resources than the smaller ones, are probably experimenting first. I think you're going to see from these 3 presentations that a lot of that is true in the publishing sector as well. So without further ado, I want to turn things over to Francis to start things off. Francis, thanks for being here, and take it away.
Thank you. Good morning, everyone. I'm going to start with how AI and NLP has increased the speed and quality of publishing. To begin with, we'll start with a brief introduction of who we are. Senvio Publisher Services has been one of the lead publishing services companies headquartered in the US, has offices in UK and in India. We have publishing solutions across journals, books, magazines, and the digital world. Our publishers' office is an extension of what the publisher is doing. Basically, it includes all of the workflow optimization and workflow experience that we share with our publishers. So we don't look at our office as just ours, we look at it as an extension of our publishers. So we tend to sync our thought process as well as our overall workflow optimization to what the publishers want and need. And so we've been able to grow with our publishers in the process. We do have expertise in almost end-to-end process in the publishing field, right from editorial management, starting from full service production or peer review management, author services, moving on to design studio, to conversions, digital, composition, print, you name it, and we have worked on it or we have touched it for some reason. So that's an introduction about who Senvio is. Today we're going to look at the artificial intelligence and NLP as a big push that is happening in the publishing world. Although it is early days, but I think the adoption of AI is becoming the key now. What is AI and what is NLP? I'd like to just set the stage here for all of us to go in deeper into this aspect of AI and NLP. AI stands for artificial intelligence and NLP for natural language processing. Artificial intelligence is the simulation of human intelligence by machines. So it's able to learn, process, and decide just like a human being would do. There are a lot of areas under artificial intelligence which we can talk about, but for today we're going to just stick to the basics of what AI is. And talking about natural language processing, it's under the AI umbrella, but it has its own stream, own way of doing things, and again, very similar. Instead of the human intelligence, here we are talking about adding value to the human language. Again, the program should be able to discern, understand, and add value to the language. And that is, the science of that is the natural language processing. In both these instances, the most important part is they should be able to do three key factors or three key areas that the intelligence should be able to work. One is any artificial intelligence system should be able to learn by itself. That is, to be able to acquire information from whatever is given in as input to the system, as well as be able to use rules to manage that information. Secondly, the system should be able to reason using the rules to come up with a decision. There is no use of the system just acquiring and accepting all the information, but to be able to reason using the rules that we give it. And the third and most important part is to be able to execute it and make changes where required so that it is useful for us in the industry. One of the key aspects is learning, because without learning, there is no improvement to the system, and that's the key in artificial intelligence. One example I can cite here for learning and reasoning is that When a manuscript comes inside the production environment, the manuscript comes in as raw without any level of styling, whether it is paragraph styling or character level styling from the author. And the systems generally are able to identify content automatically. So in a learning environment, what the system would do is it would know what the system is able to do by itself in terms of identifying content. And then parallelly, once it has completed its portion of the work, it's able to push it then to a human being who would then complete what the system couldn't do. So in this instance, let's say the system has done 90% of the work on the manuscript and has moved that manuscript to the human being who's probably a pre-editor or a copy editor. And the human being adds another 10% to it to complete the manuscript. Now the system should be able to capture that information of how a human being has completed it and learn from that over a period of time so that then the system can intelligently make decisions on identifying the content. It's like if you take it in a bigger scheme of things, if I were to give the system a group of pictures and ask the system to identify the cars in the picture, then the system should be able to use that information to identify the number of cars. Over a period of time, with more intelligence, it should be able to say what color of cars are there, and with adding more intelligence and reasoning, the system should be able to say what makes are those cars, and then with more intelligence, it should be also able to say what is the current pricing of those cars and where they are available, so on and so forth. So that's how the systems become more and more intelligent as we start giving them the learning feature. So without learning and reasoning and executing, the system is not artificially intelligent. The key advantage to this is that the error rate becomes lower and lower over a period of time. The accuracy and speed becomes greater and greater over a period of time. There is usually a tipping point in artificial intelligence, especially in the learning part. In the beginning, the system overall looks like it's learning very slow, it's understanding things very slow, but the moment it reaches a tipping point, the learning and reasoning becomes exponentially higher than a human being. So we can see a sudden big progress after a particular period with the use of artificial intelligence. Why do we need to do this in the publishing field or in the publishing services industry? One of the key areas is to automate the workflows. There used to be a time when workflow was a major constraint in all work. Somebody had to carefully monitor workflows, understand what's happening, and set schedules and so on and so forth. But today with artificial intelligence, workflows are not something that anybody needs to supervise because the system takes control of the entire workflow end to end. What happens because of that is there is reduced time to publication, and overall the workflow management is out of the way. As a result, people can then focus on the other key areas. The other great benefit is in the editorial quality. Editing has been one of the important aspects for publishing, and publishers do not want to let go of that part because that is the only area that they can add value to the content, and that's an important part of publishing. By bringing in artificial intelligence and natural language processing, the editorial quality becomes better and better over a period of time. And what happens because of that is that even a person who is publishing content, an author with a non-native English speaking experience, is able to give a good product to the market. It also boosts immediacy because in science, the sooner the better. So that is a key of moving into AI and NLP. Well, how publishers can use it? There is a whole lot of area where they can use, right from manuscript evaluation. One can use it in peer review and copy editing. in composition, in conversion, in public, right from end to end, there is a wide range of areas where AI and NLP is applicable. We have seen at Senveo where end to end, the product is able to use the technology behind AI. And that's why we call it smart, because any product is smart only when there is artificial intelligence built into the system. What we have seen is that whether it is editorial, whether it is compose, whether it is to proof sent to the authors or editors, or whether tracking the whole thing, the system is smart because of artificial intelligence, because of the machine learning. How do we get started with AI and NLP? Obviously, there are many different ways. These are not the only ways. But I think the most important is to prioritize one's goal. There has to be a goal set, whether it is 1 year, 3 year, or 5 year, to say what is important, whether it is quality, cost, or schedule, or all the three. That's the goal, and then based on that, we can start working towards achieving the goal. Secondly, editing, which is usually a time-consuming process. One has to decide what level of intervention is required, whether it is editorial intervention is important, or one can live with an acceptable automation that comes out of the system. So that's a give and take at that point. But depending on the user experience, depending on what the publisher wants to deliver to the market, they can make those decisions and move on. Most importantly, to partner with a vendor who has that required R&D investment and infrastructure to be able to support those advanced tools that is required to be able to move forward with AI and NLP. The future of AI and NLP is very exciting. Whenever I speak to publishers as well as others, I see there is a lot of excitement. As publishers continue to focus on improving their costs, the most important thing that they look for is the supplier who can scale up. Well, scale up doesn't mean, like in the traditional world, we can increase the headcount, or we can sacrifice quality, or we can increase the cost. There is absolutely no compromise to any of this. The most important is scale up without increasing headcount, without sacrificing quality, and without increasing cost. In fact, the publishers would be looking to decrease the pricing and to increase the quality. That's what the publisher would be looking at when it comes to scale up. And if somebody is ready on that, then they are in the AI area. Again, focus on science, because process and workflows and all of that is kind of controlled by the system. So the focus is now on the science, and that's what AI has done. And in the near future, I won't say in the long future, but in the near future, AI will not be completely replacing the editors, but will definitely empower them to do more and to add value. With that, I'll be signing off. Thank you so much for listening in, and we'll be handing it over to Stuart Gardner, who's the Global Production Director of Taylor & Francis Group. I just wanted to add one word here, is that Taylor & Francis has been one of the pioneers in adopting AI, and I'm sure Stuart will be talking about it to a certain extent, but we are very proud to have him as a customer and to see how they've adopted AI and they're reaping the benefit, whereas others are still lagging behind. Over to you, Stuart.
Thank you, Francis. And hi, everyone. I'm Stuart Gardner. I'm the Global Production Director for Taylor & Francis Journals. And today I want to talk to you about a kind of case study, really, of an application of artificial intelligence and natural language processing in a productionized journal's workflow, operating at scale. And in order to do that, really, I think it's good to give you a little bit of a background, really, in how we've arrived at applying NLP in our workflow. So Taylor & Francis has been working with our suppliers really since the beginning of this decade to improve the sophistication of what is commonly called the kind of pre-editing step of the journal's production workflow. So that's when an article comes from a submission system such as Scholar One or Editorial Manager into production in the journal's prepress vendor, and then a mechanical edit or a kind of a process is run across that manuscript that enriches it, structures it, and applies some rules, which Francis was alluding to earlier, in order to produce an XML document or a structured document. And what we saw really in the last 10 years or so is the sophistication of the pre-editing tools across different suppliers really coming along in leaps and bounds. I think there was a kind of a breakthrough maybe 20 years ago or so when the bibliographic databases such as PubMed or Crossref as it emerged became integrated into pre-editing tools and enabled the tools to create structured reference lists and to use the bibliographic information freely available to enrich articles with full bibliographic information. So those advances in pre-editing we thought had a great deal of potential to improve the consistency of output of journal manuscripts. And our goal was, working with our suppliers, that all the kind of interventions and applications of a journal's style policy that could be made using rules are executed in the kind of pre-edit process before the author's manuscript reaches the human copy editor. So the idea was that by the time the copy editor was looking at the manuscript, pretty much most of the routine work had been done, and the copy editor then could focus on the more kind of language-oriented interventions to fix language quality rather than apply style rules. And as we developed pre-editing sophistication, we found that we were building in kind of primitive types of intelligence into the pre-editing tools. So, for example, one of the really common things that a pre-editing tool will apply is the standardization of language. So if an article comes in, and as is frequently the case, there is a mix of US and UK English or international English, depending on how you want to call it, then the tool can apply a rule set and make the language consistent, either US or UK English. And for a certain number of our journals, we have a kind of policy which says that we don't mind whether the author submits in US or UK English as long as it's consistent. So where we have articles in those kinds of journals, the tools would do a count of the US instances of US usage versus instances of UK usage, and whichever had the highest count, it would consistentize or make consistent the lower count. So in other words, if it was predominantly US English with a few UK English terms, then it would convert to US English and vice versa. So, that's an example of very primitive and kind of early AI type rules being built into the pre-edit solution. So as we move forward with developing the sophistication of what you could call the mechanical copy editing or the automated copy editing, we started to notice some really interesting results coming through on our editor and author surveys, which showed us that the journals where we were only applying this kind of automated copy editing were actually coming out with higher levels of satisfaction, both in our editor surveys and in our author surveys. So in a sense, the computer copy editing was producing higher levels of satisfaction, which we found to be counterintuitive. I mean, our intuition was that the gold standard of copy editing was the traditional onshore UK-US freelancer working from home often with a bit of subject matter expertise in the field, and that second tier of copy editing was a copy editing performed in India or the Philippines with a prepress vendor. But actually what our results showed, and with some, not by a huge margin, as you can see by the numbers on this slide, but certainly with the editor satisfaction, with a reasonable amount of significance, that the automated copy editing was ahead of the other two options. So that really led us to think, well, actually, there is real potential here to remove some of the copy editing interventions that we were making with human copy editing in order to improve the consistency of outputs. Now, analysis was really showing us that the reason why we saw dissatisfaction with human copy editing was generally because human copy editors are often over-intervening in authors' manuscripts or changing things which don't need to be changed or interfering with the meaning of an author's English. Whereas the mechanical copy editing is really just applying a set of very well-defined rules and producing a high level of consistency as a consequence. However, having said that, I think we're all pretty aware that we are never going to eliminate the requirement for human copy editing of journal articles. And the kind of traditional craft skill of copy editing will continue to have a place in journals publishing. And part of this, I think, really reflects the fact that the geographical origin of journal authors is becoming more and more diverse every year, which is leading to a kind of very high level of variability in language quality in articles submitted to TNF journals. So we acknowledge that there's a proportion of articles that still require a old-fashioned human read-through and correction. So the challenge that we set our suppliers was to develop kind of algorithms or artificial intelligence into the workflow which could separate articles on the basis of language quality and work out what articles needed the human intervention and what articles could get by without it. And if you can imagine a traditional editorial office of perhaps a society journal or a relatively modest scale journal operation publishing a few dozen papers a year, traditionally a desk editor might have a look at articles as they come in and make a decision, eyeball the incoming articles and make a decision about what kind of copy editing channel to send that article on. But for a publisher like Taylor & Francis, which publishes 2,500 journals and about 150,000 articles a year, we have thousands of articles flowing through the production process every month. And the ability to operate at scale means that we can't have human beings kind of eyeballing papers as they come in. So what we needed was a technological solution. And we felt that the development of natural language processing and AI had reached a point where it was feasible to develop a system to assign copy editing to articles with automation. So the tool that we've developed with Synveo uses natural language processing to assign articles to a copy editing channel which is contextualized for the article's language quality. So how it works? Well, the incoming article comes into production pretty much the same as it did 10 or 20 years ago, and it's structured through the pre-editing process. So the pre-edit happens as it would have, but then after the pre-edit happens, we then apply an NLP processing step, which parses the text. The pre-edit has structured the document, so we know what's references and we know what's the main body of the text, what's the abstract, and so on. So the NLP processes or parses the body of the text, the main body, and then tokenizes that content into tokens of language, and then uses the kind of algorithms of the NLP set to score the quality of the language in the article against what we consider a kind of consistent grammatical rule set. And this scoring then gives us the opportunity to kind of sort articles into three categories. Category A is the no edit category, and those are the articles that don't need human intervention. They're the well-written articles where the machine editing is perfectly sufficient. Category B are articles that have a requirement for some editing, and those articles go through to an offshore copy editor or a copy editor based at Cenveo for what we describe as a guided edit process, and that is a process where the software or the copy editing software guides the copy editor through the article and takes them to those instances in the article where it has identified a language problem. And then the copy editor assesses that language problem, makes an edit if it's required, and if it doesn't require an edit, if it's a false positive, then flags it as a false positive, and then moves on to the next instance that the software has identified as a problem. So that speeds up the kind of copy editing process by really focusing the copy editor's attention on problems that the tool itself has identified. And then a much smaller subset are the articles that have real language issues. And those are the articles that go through to the traditional full read-through with predominantly with an onshore UK, US native English speaker copy editor for review. And you can see by the pie chart here that this segmentation has reduced our reliance on those kinds of onshore copy editors quite considerably, with only around about 8%, we think, in a mature model requiring onshore copy editing. So the benefits for us in developing this approach is that the copy editing process is no longer a bottleneck. And it's fair to say that traditionally in journals publishing, copy editing has always been something of a bottleneck in the production workflow, in the sense that traditional workflow where you've got one copy editor assigned to a journal, and the editor accepts maybe 10 or 12 papers, then the copy editor's got to get through all of those papers, and it can be reliant on the copy editor's schedule if they've got other journals that they're working on, or if they're taking a vacation or what have you. Things build up on the copy editor's desk. But that is no longer a problem for us once we've adopted this approach. The other advantage is that well-written articles can be processed much faster. So where an article comes in and the language quality is scored on track A, our expectation is that pre-editing through to proofing can be done in about 24 hours. So the goal for us is an author who's perhaps a top-flight author writing a very high-quality paper, can have their paper accepted in one of our journals on a Monday afternoon in the US, let's say, and then by the time they wake up the next morning, they've already got a proof of their paper to review because it's been through the process, it's been assigned to the no-edit channel, and it's been typeset. And we think this really will improve author satisfaction, which we know is strongly correlated to the speed of publication. The other advantage is that we stop over-intervention during copy editing, and I alluded to that earlier, that one of the problems of copy editors is that they feel in order to earn their keep, if you like, in order to charge us the money, they have to make interventions, and even a perfectly written article will need some intervention rather than just being effectively proofread and approved. So by applying a rules-based approach, we can be absolutely clear on what items are going to be receive intervention and what are not. And the well-written articles aren't touched. So of course it also reduces costs by eliminating the waste activity. And if you think about 20 years ago, 100% of our journals going through the freelance copy editing to a world today where possibly less than 10% get that treatment, then that shows you really the scale of activity that we no longer need to do now that we've got an NLP solution in place. And it also means that there's less dependency on freelance workers and their kind of erratic schedules, and the need for them to take, perfectly understandably, of course, to take holidays and so forth. In a modern world, expectations from authors and from editors are that work proceeds regardless of whether or not people are on vacation. So we don't have that dependency now. So what are we doing? Where do we take this? What's the next steps with our program? Well, I think the first thing is to really get the machine learning working effectively, so that in that guided copy edit track where the copy edit is taken to the problem areas in the manuscript, we can start identifying areas where the tool is incorrectly identifying interventions or effectively false positives are being flagged, and we can start to work on developing a learning feedback loop which enables us to eliminate some of those false positives. The other thing which is really interesting is that editors are asking us if we can apply this language analysis tool at the point of submission, so that they can quickly assess an article that comes in. If it has got poor language, it can be sent back to the author with a recommendation to use a language improvement service. And the example that I've given here is our language editing services, tndfeditingservices.com, but there are a number of editing services out there which can help authors develop their articles and improve their language so that it has a better chance of being accepted into a journal. And then, of course, the next step on from there is a kind of self-service model where authors can upload manuscripts and the scoring of the quality can be returned to them, which can effectively give them some guidance on how they can improve the language of their articles. Potentially could be a valuable service that we as a publisher could offer authors. And that possibly is a little bit more futuristic, but I think those are the kinds of things that we see this approach using NLP could potentially lead us to put into production in the future. So that's me done. I'm going to stick around for questions at the end if anyone's got any, and I'm now going to hand over to Neil from Unsilo.
Hey, thank you so much, Stuart. That was very interesting. I'll have some examples too. First, I'll share with you, a few use cases in the sort of post-publication space, and then we'll go into a bit more detail for a couple of use cases in the pre-publication space, if you will. But a few words first. So I'm from Unsilo. We were founded in 2012, and we specialize in text analytics, NLP, and machine learning. And we work with a number of publishers and information services. Overall, I think much of what we're addressing in today's webinar, or at least I've heard in the past two presentations and in mine, I think a lot of it has to do with information growth, right? And people's relative capacity to digest that growing information when time is a constant, right? So we only have limited amount of time. Oh shoot! Oops, Alexa. There. So we only have a limited amount of time, and how do we deal with this increasing amount of information that is available to us to do some great things, but also sometimes puts us under pressure to get things done. So I'll first show three quick examples of these post-publication use cases, and then I'll look at two pre-publication use cases in a bit more detail. The first one here is a quick example, related content for readers over at Taylor & Francis. Now, behind the scenes, what's happening here is that the software extracts concepts from the full text, so in this case, the different chapters from this book. And then there's an API that surfaces similar content based on overlapping concepts. So this all sounds quite simple, but the quality of recommendations here is actually quite critical if you want readers to find value in the suggestions that you surface and actually click on them. Now, and sometimes you'll find recommenders in this space that are fairly simplistic in their design. They rely on basic title, abstract data, usage data, but that may sometimes result in less useful recommendations, right, when that metadata is maybe generic or esoteric. So imagine generating related content for some titles in social science and humanities. It can be quite difficult to read limited title information or abstract information there, and then determine what a suitable related piece of content is. But that you need to go deeper. You need to go into the full text. And in this particular case, this full text concept extraction that we use here generates higher quality results. We've run some A/B tests, or some of our clients, partners have and have seen these related suggestions generate 150 to over 200% more click-through than alternative recommender solutions. Supposedly, of course, because we're putting more interesting and more relevant things in front of people. That was the first example. The next example here is of a binary classifier that we custom built for Springer Nature's Nano service. So what's happening here is that we analyze content feeds from 26 or so participating publishers, and then we have this custom classifier that's able to determine whether or not a single piece of content is about nanotechnology or not. Right. So in the field of nanotechnology, of course, you can have things being published in chemistry, in social science, in medicine, and engineering journals. And if you were to try to build a journal level index of that, you would just have like a hodgepodge of a lot of different journals, and you would have the likelihood of including content that isn't necessarily relevant. So what they were after here was an article level index, where we're able to handpick on an ongoing basis which content fits the topic. The full text concept mapping that we do here also allows for some other pretty cool stuff, I think. So in this example, if you look up in what you call it in the search bar, it says titanium dioxide, and the software understands that really this is synonymous with titanium, and it's able to let readers know that in that context, when you look down here where it says this article discusses, it's able to understand that when you're interested in titanium dioxide, synonymous with titania, then from having analyzed what goes on deep inside the article, we can tell you that this article discusses titania with mesoporous titania, benzalkonium chloride, et cetera, et cetera. We understand the relationships of the different concepts and phrases inside the content. We're able to sort of generate this super condensed summary for a subject matter expert who may just want to know, relative to what I searched, what's going on inside this article, without me having to read a generic abstract or start skimming through text. The third post-publication example I'll show you here is from Carter, where they use a tool called Classify. It's another type of classifier software that we've created to help build and maintain many different topic packages. And it's a bit too much to show here, but really it's a software that helps guide staff in what to include or exclude in one or multiple collections. And there's a lot that goes into that software, but it's just to give you some quick ideas for what are some of the things that are already in production, already deployed, that are being used post-publication. Now I'd like to just peek a bit behind the scenes, and my apologies if you've already seen these type of rainbow color slides before. We're not going to stay for long in them, but it's just to give you a brief background of what's going on in some of the methods and tools that we use. So traditionally, document fingerprinting, linking, and searching has been based on a fairly rudimentary understanding of text. So the common or a common automated version of fingerprinting has been to look for words that we know the meaning of, count their frequency, and then use that to make fairly simple determinations of what the text is about and how it may relate to other texts. You can, of course, do some fuzzy matching of concepts, but by and large, you're going to find what you predefine, right? So if your taxonomy is so big, you're going to be able to find so much content, and if it's so small, you're going to be able to find less content. By and large, it's not cut and dry. So in many of our solutions, we take a very different approach and sort of a taxonomy-independent approach. So we analyze thousands or millions of documents and figure out dynamically and automatically which phrases are in common use across the corpus. We also understand which phrases approximately mean the same thing, even when they contain different words. And that means that when new terms are published, they automatically become part of our calculations. Right? We don't wait years or months or weeks for a taxonomy committee to decide what to include in a list of terms to look for. Rather, we take an approach to look for patterns amongst the words that researchers and authors have spent hours and years deciding to use in their domain, and then extract the ones from there that are meaningful. So as part of doing this, right, the software detects all context of phrases that you can imagine being found across a corpus. And that's used to further calculate similarity of concepts and phrases and understand what a phrase is about. So here's an example, right, of imagine we analyze a large corpus, right? Every single phrase that you find in that corpus, we are mapping the context of how that phrase or that word or that concept is being used, right? And that can be used to tell us a lot. We'll look at some solutions in a sec. In this case, indirect potentiometry. So now I'm going to go to two examples here in the pre-publication space, and we'll have some time to dive a bit deeper. So the first one we'll look at is about finding reviewers, right? This is a task that's fundamental to research publishing, you know, but it's starting to run into an increasing amount of problems, right? The amount of invitations that have to go out to find one reviewer is increasing. A vast proportion of editors are now starting to say that finding reviewers is actually the hardest task of the reviewer workflow. And one of the common reasons for declining is that reviewers are being sent invitations to review manuscripts that don't meet their own sort of expertise as a reviewer. And what is expertise as a reviewer, right? Of course, you have some skill in reviewing, but it's really dependent on your expertise as an author. You know, do you have expertise to review other things in that area? One of the challenges is that that editors, tend to use keyword profiling on reviewer profiles, and they are often outdated. Sometimes a reviewer profile isn't updated for years, and sometimes they use generic terms, right? So I've seen reviewer profiles where it's like a keyword tag like cancer. How on earth are you ever going to find a manuscript that matches the specific expertise of that person? Cancer is so many different things, and there's a recruitment challenge, getting enough people sort of recruited to help with this very, very large task. And that just means days and weeks of delays in finding people, right? You send out a couple of invitations, maybe you hear back from one in a couple of hours, another one it takes a week, you have to chase, and after 2 weeks they tell you, oh, actually I looked at the abstract you sent me, I don't think this is a match with my expertise. And that takes a lot of energy. And it's dissatisfying for authors, editors, and reviewers altogether. So here's a manuscript that we'll analyze, and then we're going to return a suitable list of potential reviewers for it. So this shows the UI just for demonstration purposes, but in the example, imagine this manuscript is submitted to a journal, and then it's passed automatically through an API, and then in the next screenshot, you will see the API returning a list of suitable reviewers based on a real-time analysis of that manuscript in question and relative to the authors we have found in the 28 million records in PubMed. All this happens in the background. No user has to do anything. The editor will simply log into their online review system, and then you'll see a list of suggested reviewers for each manuscript that you need reviewers for. So here you go. So here are the suggestions of authors indexed in PubMed. You have that over here on the left, and then you just have the text here on the right. So focus on what's going on the left. So again, just to say, this is a UI for demo purposes, right? The data on the left can be, surfaced in any type of online submission and review system, and shown in whichever design that system uses. The concepts that you see here, where it says match between reviewer top concepts and manuscripts, are specifically matched to the context of the manuscript. Right? Dr. Lucatelli here may have other high-scoring concepts to his name, but they're not being shown here because they're irrelevant for the particular manuscript, right? So the software helps us sort of remove the noise for why this person is maybe of particular importance or relevance to this manuscript. Also, what happens is that they actually reflect what Dr. Lucatelli publishes. Right? They're not based on someone going into a system and then logging in keywords. They're based on an ongoing analysis of what's being published. Every time Dr. Lucatelli publishes a new article and an index in PubMed, right, that may change our appreciation and understanding of what his expertise is, all depending on, how much his expertise is evolving versus what he published prior. Another thing the system does is it automatically detects co-authorship of review candidates. So it here on this list, you don't see anyone who has co-authored with any of the authors in the manuscript in the past 3 years. That would be a typical conflict of interest. And what you don't see here, that would be another screenshot, is that as an editor, if you've never seen Dr. Lucatelli before, and you're like, who is this person, you can quickly pull up the 3 most recent, most similar articles that Dr. Lucatelli has published that would make him an expertise for this particular manuscript you are looking at. The system automatically understands how to match abbreviations to and synonyms. Right? So between a manuscript and a reviewer candidate's publishing expertise. And that means that we're able to find experts even when they have used other words to write about a topic that matches this manuscript. Sort of back to those phrase embeddings I showed you before. The last example, I'll be quick here. On the second use case, we'll look at selecting or suggesting appropriate references for study. Whether you're an author or reviewer, right? Reference selection sounds a bit boring, but it's really fundamental because it helps demonstrate the context and contribution of the new study, right? You show why this is important by filling people in on what do we know as a civilization, what has been published before on this particular topic. So using the correct references to frame a contribution or the importance of the study really can make a difference between acceptance and rejection, or really frame why is what we found here important? Well, because this is what we knew beforehand. We know that reviewers routinely suggest missing references to authors. That's part of the reviewer task. But we also know that many reviewers rarely do real literature searches, but sort of rely more on memory to suggest references. So here we use software to run an automated sort of related paper search against each manuscript. I'll show you what that looks like. So in this example, right, it's the same thing. We analyzed it against 28 million records in PubMed, and now it's suggesting which papers you may want to consider taking a closer look at as references for this manuscript. Right? It also will look for which ones you may already have referenced, the green button down there, and it may also look for the references that you may want to consider that are highly cited, so seminal papers, where everyone else who's writing about this topic tends to be using this as a base citation. Maybe you want to give it a look too. But it can also be used further upstream when authors are researching a hypothesis or framing their study sign, writing grant applications, writing research outlines, anything where they have a piece of text and they want some quick real-time feedback on what else is going on in that topic. The final one I'm going to show you here is just we had a hackathon last week that focused on trying to hack together solutions to authors because we're realizing that there are many of the things that we're working on that are ideally a bit too late to address at the point of submission. So in this one, just as a final piece of inspiration, as an author is writing in Word, the favorite, maybe not understandable to many, but a favorite tool for many authors to write in. There's a plugin that sits out here to the right that analyzes the text and makes dynamic suggestions for which related papers you may find in this space, right? So this way you get to interact and help an author weeks, maybe months before they even get around to submitting it to your publication or to a publisher. You will also just use it as an inspiration tool for authors upstream. And once you're in this plugin sort of mode here, there are a number of other things that you may be able to suggest to the author, right? Maybe there are various guidelines for how to write up to certain studies. Right? You use like Consort for randomized trials, Arrive for preclinical animal studies, and so on, where you can help give authors guidance. And because you're in the writing environment, you have a very clear idea for machine learning purposes what they are writing about when they're writing, rather than trying to like analyze a paper afterwards and then guess which things fit. You can also find maybe suitable journals too and give it to them, help with title abstract optimization. In general, just help maybe more inexperienced authors with suggesting structure or phrase. And that wraps it up on my part. I think there's a lot more to discuss and learn, right? A lot of this stuff is really, it's not like a thing. It's a toolbox. It's lots of different things you can do with some of these tools and methodologies. But to do any of them right, you really need to narrow down on what problem you're trying to solve. Without a clear understanding of what problem you're trying to solve, it's very difficult to just sort of reach into your toolbox and then start putting things together. You need to have a very specific problem before you can start building solutions for it. Thank you.
Neil, thank you very much. That was terrific. Francis, Stuart, your presentations were as well. We appreciate it. We do have a handful of questions. We have a lot of questions. We only have time for a couple of them. So as you each take a breath and get ready for our speed lightning round of Q&A, I want to point out quickly that if the audience is interested in more information like this, Senveo recently published a fantastic white paper on AI and NLP for publishers. I'd urge you to check it all out. It is available to be downloaded right from your portal here. If you look for the green resources folder at the bottom of the screen, you should be able to download the AI and NLP white paper right from there. So as I mentioned, we're short on time, so I'd like to get to at least one question to each of our three speakers today. Let's go back to Francis. Francis, if you're with me, my question for you is can you talk about overall production time savings? What is realistically possible in terms of time savings because of automation like AI and NLP?
Well, what used to be taking several days is now possible to complete within hours. That is the biggest move because of artificial intelligence. One of the other advantages that in a traditional workflow, the manuscript would pass through various departments and would have a mandatory stop at every stage, which used to be time-consuming. We call that as shelf life, which means the manuscript is really not doing anything, but it's stuck in a department because somebody has to attend to it. But with AI, there is no need for that because the system is moving it along, so it only stops where intervention is required and keeps moving it along. So I would say anywhere between 30 to 40% improvement in the overall speed is possible, and if we use the process that Stuart described, especially where there is no edit required, then it's a matter of hours to get it out of the door. Thank you. Great.
Stuart, the next one's for you. We have a couple of versions of this question, which essentially is have you seen any has it been difficult to get buy-in from editors in particular? Did you encounter any resistance from editors as it related to automated copy editing? And if so, how did you guys overcome those objections?
Yeah, that's a really good question. And yes, I mean, certainly there has been some editors who really don't don't see the value of having these decisions made by computers. But then most of our editors are actually authors, so they've had the experience of submitting articles to journals and having had some ineffective copy editing applied and being upset by it. So they kind of get it. But generally speaking, once we put the service into production, we find that the satisfaction levels with editors are very high, just because it improves the publication speed and it reduces some of those author complaints about inappropriate copy editing.
Great. And then Neil, let's end with this question for you. When evaluating manuscripts and pulling out key statements to analyze for novelty, reviewer, or journal matching, have the AI-powered findings ever returned unexpected or misguided results?
Yeah, absolutely. So this is where it's really like, we're working with different tools here, and we're working with those tools with a particular sort of problem solution in mind, and it's rare that you can just grab any sort of a set of algorithms, slap them together, and there you go, it just works, right? There's a lot of fine-tuning that goes into this, into making the algorithms work just the way you want them to work. So I have an example from our classify tool, where during part of the evolution of that tool, we really turn on the machine learning on that, right? And every time a user decided, I like this type of content from my collection, I don't like that type of content, the software was learning, and it was paying attention to what you were picking, and then it influenced what it would show you next time for your collection. We actually had to turn that off again because many of the end users for that tool they didn't feel in control of using it, right? They weren't quite sure that when they just haphazardly said, I'm not interested in this piece of content, they couldn't understand what the ramifications were going to be for the future composition of their collection, and they wanted more control. So there are some things where we turn it off, but it's an ongoing massaging and a lot of conversation with end users constantly to understand how their problem is being addressed and solved, and then just flat out having to admit that this is not a 100% type of solution building, right? There's a lot of calculation. It's very statistical, and you have to be sort of very cognizant of what wheels you are turning when you build tools here.
That's great, Neil. Thank you for that, and thanks to each of our speakers. We could probably go on for another half hour if we had the time. Unfortunately, we don't. For those of you who submitted questions we didn't get to, I will be passing those along to all of our speakers. They'll have the ability to follow up with you guys individually. Some of these questions are highly specific to probably your own use cases or applications in your own organizations. But I want to thank everyone for joining us. On behalf of Publishing Executive, Book Business, and Senveo Publisher Services, I especially want to thank our speakers and all the time and energy they put into putting together the presentations today. Be sure to check out our webinar page at bookbusinessmag.com to get information on all of our upcoming and our archived webinars. And if you would, please take just a quick moment to fill out a brief feedback survey that's going to appear on your screen next. We'd be very grateful. It helps us. It helps influence us in terms of the type of subject matter or topics we cover down the road for your audience. So again, thank you for joining us today. We hope to see you at our next Publishing Executive and Book Business webinar. Thank you very much.